Assalamualaikum warahmatullahi wabarakatuh, and welcome to class Dynamic ECS 429. Today is week 1 and it's dated 21st March 2024. Okay, first of all, I am sharing my slide in the screen. Can you see it?
Yes,
Yes.
teacher.
All right, you can see. All right, so for today's class, we are going to start with our first topic, which is on kinematics of particles. When we talk about the word term kinematics, what it means is it refers to uh, the geometric aspect of the motion, whereby we will be focusing. Where's my? Hold on. Yeah. Okay. Where it focuses on velocity, acceleration, and position. Okay, these are the symbol and time also. Okay, all right. So let's go to the next slide. Is there anybody trying to enter? Okay, I will admit. Okay, going back to the slide. Okay, now when we talk about analyzing a particle, it means like what we can do is even though we have big boats like you see in this diagram and the boats are far away from a distance, we can analyze it as a particle. Okay, as I mentioned before, it can be large as an aeroplane or as small as a pen. We can analyze it as a particle. And when we analyze it as a particle, for example, the car, the yellow Myvi car, you can see what we can do is we can analyze the position, the velocity, and the acceleration of the motion of the car. All right. So basically, what we do in topic one, kinematics of particle, is we are analyzing the motion of the particle. But when we talk about using the kinematics concept, it means that we are not involving any forces. We only consider the geometric aspect, motion. Okay. All right. So let's look at the next slide. Okay. Engineering mechanics. So, what is engineering mechanics? So, engineering mechanics is the study of how rigid or non deformable bodies react to force acting on them. So, when we say the thing is rigid and non deformable, it means that it cannot change shape and size. Okay, like jelly. Jelly, you can change shape and size. Okay, slime, it can change shape and size. No, but when we study the engineering mechanics, we focus things that are cannot change, that are unable to change the shape and size. Okay, now, so I guess most of you are survival of statics. However, again, if you did not pass statics, you can still take dynamics course because it's different. Okay, it's not a continuation and it's not a prerequisite subject. Okay, all right. Now, so what is static? Previously, you studied static. Static actually focus on bodies that are in rest, but or moving at a constant speed, but in the same direction or considered almost rest. But dynamic, it can change position. Uh, and it doesn't mean that it's moving in a constant speed. The speed can also varies. That is dynamics. So in static, previously you focus on the formula of Newton's first law, which is the resulting force acting on a body equals to zero, F equals to zero. Okay, so that was static. Now we are gonna, in this semester, you are taking dynamics and you're gonna study the motion of an object, whether it's a particle or a rigid body. But in this case, for topic chapter 1, it will be a particle. Okay, so in dynamics, there are two types. We can say kinematics and kinetics. So again, I said to you previously, kinematics focuses on the geometric aspect, which is displacement, velocity, acceleration, and time. And kinematics does not study how motion is caused by the force acting on the object. Compared to kinetics, is the study the force acting on the body or the mass of the body. So when you talk about the force acting on the body, forces can be due to pushing force, forces of a cable, and mass of the body is also the weight, the mass. Mass of the body, which has a weight, is also considered as a force. And then the friction between the surface from one to another is also considered as a force. And this is using the Newton's second law, which is F equals to ma, whereby m is the mass and a is the resulting acceleration. Okay, all right, let's go to the next slide. Okay, in topic subject dynamics, there are actually three main formulas. Okay, the main formulas is V equals to ds dt, A equals to dv dt, and ADS equals to VdV. Okay, these are the three main formulas in dynamics, and these formulas are called basic kinematic formula. Okay, so V represent velocity, S represent position, displacement, and T represent time, and finally A represent acceleration. So the unit for V velocity will be meters per second. The unit of position will be meters, and then the unit of acceleration will be meters per second squared, and finally time will be in seconds. So again, the three basic formula which is important is these three formulas. The one I highlight here. Okay, these are the basic formula. All right. Okay. Now again, from the first formula and the second formula, you can see you can create another formula, which is formula number 5, which is the third formula that I said, which is important, which is ADS-VDV. How you derive that formula is that you equate the two formulas together, but you replace dt on top and you replace v at the bottom. Same with the acceleration, dt on top, a at the bottom, and then you will come up with this formula. From here, you will bring a on the top, you bring v here on the top, and it will be ADS equals to VdV. So these are the three basic kinematic formulas. Okay, all right. Now we do have other formulas here in this screen, but these other formulas you can see actually is the derivation from the basic kinematic. However, we will not go into detail for now, but I will just like to let you know what is it. Number 3 formula is Newton's second law, which is F equals to ma. Formula number 4 is the equation that relates to the length of an arc. Let's say this is S, this is the radius, this is theta. Okay, so is what you call the length of the arc. Lilitan bulatan in Malay, you say it. Okay, and then if you can see, if you use Newton's second law, this one is Newton's second law, and then you combine it with equation number 5, what you will get is principle of work energy formula. And then from the second equation, acceleration equals to dv dt, you equate it with Newton's second law, you will get the seventh equation, which is the principle of linear impulse and momentum. But not to worry, for these other formulas, we are not going to be using it right now. We're only going to focus on the basic kinematic equation. Okay, so when we talk about the basic kinematic equation, if you remember, what is it? V equals to ds over dt, and then a equals to, if you're opening your mind, just say it. It's okay. It's good to have two-way communication. ADS equals to VdV. So these are the three important equations which we call the basic kinematic equation. Okay. All right. So from this basic kinematic equation, you have to observe what are the variables and the unknowns that are given in a question, and then you can decide which equation that you want to use to solve the problem. Okay. And at the same time, let's say S is position, V is velocity, and A is acceleration. If you have a position, equation of a position, and you are asked to find the velocity, what you can do is you can differentiate. Again, if you have a velocity and you want to find the acceleration, you can differentiate the velocity. You can do a differentiation. Okay, but then if you have acceleration and then you need to find the velocity, you can integrate. Again, from velocity to find the position, you can integrate. Okay, all right. So these are the basic kinematic equation in topic chapter 1, and these are the flow if you want to solve a problem. Okay, all right. Now, okay. Now what we will do is we will do one simple question that uses these equations to make you have a better understanding on how to use it. Okay, do you have your books ready? I ask you to everyone to buy a book so that they can copy the question. Do you have them ready?
Yes, doctor.
Okay, so you can copy this question. Okay, I will read it out. The car moves in a straight line. The car moves in a straight line. Okay, such that for a short time its velocity is defined by v equals to bracket 0.6 t squared plus t close bracket meters per second, where t is in seconds. Okay, now the question is determine its position and acceleration when t equals to 3 seconds. Okay, and then t equals to 0, s equals to 0. Okay, so we have a car here. Okay, let's draw the car. So let's say it's moving in a straight line, is going to the right here. The acceleration and velocity is to the right. And then let's say it starts from here. So this is the position S. Okay, now, how to answer this question? Okay, now, first of all, When you get this question, you need to identify what method you want to use. But obviously, this is the first method that I'm teaching you. So obviously, you know that the method is, of course, using the basic kinematic equation. Okay, all right. So the car moves in a straight line. Now, when we say a straight line, another term that we use is that represent a straight line is what we call rectilinear motion. Okay, so the car moves in a straight line such that for a short time its velocity is defined by v equals to 0.6 t square plus t meter per second. Determine its position and acceleration. Okay, so when you look at this equation, you know that the question is in terms of function of time. So this is another clue that you must take note. Okay, is this in the function of time, the velocity. Okay, now the question is, it gives us the velocity, but it asks you to find the position and the acceleration. Okay, now from from the equation of the position, how are we going? Sorry, from the equation of the velocity, how are we going to find the position? What are we going to do? Can anyone give an idea?
Integrate.
Yes, integrate. So let's go back to this question. So integrate, but which equation you want to use? Which variables and unknowns that we have and which equation is suitable? Which one has the velocity, displacement and time? Do you understand what I mean?
V
If you
equal ds over dt.
Yes, V as of D. So first of all, you have to write that equation down first. V equals to ds over dt. And now that you know that you need to integrate it, so what you do is, and you know that you need to find the position, so you will leave ds on the left side. So ds will equals to v dt. Okay, all right. And now you need to integrate on the left side. For position, it will start with 0 to s, and on the right side, you will integrate it from 0 to t. So again, we write back that formula, and what we need to do is replace v with 0.6 t squared plus t t dt. Okay. Now, so if you integrate ds, of course you will get s minus 0. Okay? And if you integrate 0.60 square, what would you get? Can you please integrate for me? 0.60 square.
1.2 T.
Are you sure? What is, if you integrate 0.60 square, what would you get?
1 over 5
1
e
over
power
5
of 3.
t3.
TQ over
Oh, over 5. So if it's over 5, it will be 0.2. So am I correct? 0.2 t
Power
cube.
of 3.
Is that correct?
Yes.
Okay, plus t 0.5 t squared. Okay, so you already have the solution and you can solve the problem. So you can find what is s. What you need to do is replace t with 3 seconds. So can you replace t for with 3 seconds and get me the answer? Are you trying to find your calculator?
9.9
Yes. What unit is it, my dear?
ampere S. Eh,
Meter.
so
Meter,
meter.
yes. Ah, ampere S. No, no, meter. Okay, because this is for position. Okay, so that's the correct answer. So now, how can we find the acceleration? From the velocity, what can we do to find the acceleration?
Differentiate.
Yes, differentiate. So again, we can do the same thing. And then the equation that is suitable, that has all the variables, will be A equals to ds over dt. So how are we going to do this? So A equals to ds over dt. So A will
A
be,
over A equal to dv over dt or A equal to
yes, you are correct. Okay, saja testing. Okay, jangan nangis. Okay, so A equals to dv over dt. So then what you do is you A equals to d over dt. So you write the v value just now, which is 0.60 square plus t. Okay, and then you can differentiate it. So if you differentiate 0.60 square berapa? Ni differentiate pula. Just now I think some of you,
1.2 t.
yeah, 1.2 t plus
1.
1, yes. So now what you can do is replace t with 3 seconds to get the acceleration. So what is the answer?
4.6
Okay. 4.6 what?
Meter
meter per second.
over second square.
That meter per second squared. Please get the formula equation right, okay? 4.6 meter per second squared. So very easy questions, okay? So for this basic kinematic equation, you must be able to read the question carefully. Understand that the question is the function of time. That's why you choose this method to solve. Next, you have a look whether you need to differentiate or integrate it, or you can use the formula directly. It depends on the question, but that is how you can do it. Okay, so that is a good start. So now we will continue the a second formula. So the second formula that I want to teach you is we want to use a formula which is constant acceleration formula. And how we get this constant acceleration formula is where we derive it from the basic kinematic. Okay, so the next part is the constant acceleration formula. So the next is constant acceleration formula. So from the constant acceleration formula, okay, we're going to derive from the basic, we are going to come up with a new equation. Okay, so the basic just now we have three equation. A equals to dv over dt, and then v equals to ds over dt, and the other one is a dv v a is a adv or ads? What did I write? Oh, sorry, ads.
VD
Yes, one is wrong. ADS equals to VDV. So what we're going to do is we're going to come up with another formula. Okay, but we are going to derive it from the basic formula. And this formula is what we call constant acceleration formula. So I'm going to open the slide again to show you. Okay, all right, hold on, skip this. Okay, so now from the basic formula, we are going to come up with a constant acceleration formula. So we're going to use all these three basic formula back. Okay, so constant acceleration formula. Okay, all right. So as you see in the picture beside here, when the ball is released, it has zero velocity but an acceleration of 9.8 meter per second. Okay, this is an example of a constant acceleration formula. Okay, it means the acceleration is constant and the acceleration will be negative 9.81 meters per second squared. Okay, now, so how are we going to derive the equation? Okay, let's have a look. Okay, so above here is the three basic kinematic equation, and the basic three kinematic equation, which is positive position, velocity, acceleration, are all function of time. And now we're going to look at a special case where acceleration is not changing with time, or the rectilinear motion has a constant acceleration. So we're going to derive new equation to solve the rectilinear motion, but has constant acceleration. Okay, constant acceleration. Okay, now have a look at this first formula, which is A equals to dv over dt. So we have A equals to dv over dt. So what we do is we bring A dt, apa? We bring, sorry, we bring dv on the from the right, we bring to the left, and then we bring dt up, okay, beside acceleration. So then what you do is you integrate on the left side and you integrate on the right side. So here it is. Okay, so when you integrate dv, it will be from v naught until v dv, and then when you integrate the acceleration dt, you will integrate it on towards 0 to time t, 0 to t. Okay, all right. So when you integrate dv, it will be v minus v naught, and you when you integrate time, it will be act. I mean, when you integrate ac, it will be act because ac is a constant. Okay, so now you will end up with a new equation, which is v equals to v naught plus act. So this is the new equation. Okay, so we'll be using this equation a lot. Okay, so for acceleration equals to dv dt, we will get v equals to v naught plus act. All right. Okay, so this is the first constant acceleration formula. Okay, let's look at the next constant acceleration formula. Okay, for the second constant acceleration formula, we are going to use v equals to ds over dt, whereby we bring ds on the left side and then we bring dt on the top, it becomes v dt. So then again, our v we will replace with this because we have already identified v is equals to v naught plus act. So now we can differentiate the left and the right. So here we differentiate the left, this differentiation ds s naught to s, and then we differentiate on the right uh, towards time, and then this is the answer that we get. And for simplification, this is it. So for simplification is s equals to s naught plus v naught t plus 1 over 2 act squared. So if you do not memorize this formula number 8, it's okay. You can always go to the basic kinematic equation and differentiate it and integrate it. Did I say differentiate? It's not integrate it. Okay. So for the next formula, if we go back here, do you remember, guys? What is it? S equals to S naught plus V naught T plus 1 over 2 ACT squared. Now, again, I will remind you what is V. V is what you call the final velocity. What is V naught? V naught is the initial velocity. Similar with S. S will be the final, what you call position. Okay, maybe I have to write this down. And S naught will be the initial position. Because when you analyze something that is moving, it might have a initial velocity and of course it will have a final velocity. Same with position, it will have an initial position where it is, and then it will have a final position. Because what we're doing is we're analyzing 2 points, two different points. But using this formula is related to constant acceleration. So how do you know when to use this formula, the constant acceleration formula, or when do you know that you need to use the basic? You need to read the question carefully. The moment it mentioned constant, you must use constant acceleration formula. Then we go back here. Okay, all right. So the final formula is ADS-VDV. So what you do, you just integrate the left side, you integrate the right side. So you will get this equation, AC in bracket S minus S naught equals to 1 over 2 in bracket V squared minus V naught squared. And then you will simplify this equation and will get equation number 9. Okay, so here it is. You see, on the left side here, this is basic kinematic equation, and on the right side here is the constant acceleration formula. Okay, so if we write back the formula here, we know that v squared equals to v naught squared plus 2a in bracket s minus s naught ac. So this is the third formula. Okay, so these are the formula for constant acceleration. So for constant acceleration, this will be formula. This one will be formula, and this one the formula. Okay, six important formulas today. So now maybe we can do the exercise that is related to constant acceleration formula. I will forward you the question. Okay, wait. Let me get the question. Okay, you seem very quiet, all of you.
Masih ada lagi.
Dah tak larat ya? Saya pun dah tak larat lah. Lepas tu lepas ni ada kelas lagi, but never mind. Okay, right, okay. So I have posted the question in your WhatsApp. You can download the question. Okay. All right. Okay, guys, let's read the question. Okay. During a test rocket travels upward 75 meter per second, and when it is 40 meter from the ground, its engine fails. So let's say we have a rocket here. This is a platform. So let's say the position here is 0, but when it is at 40 meters above the ground, the rocket has a velocity. And what is the velocity? The position here is 40 meters, and the velocity that it gets is 75 meter per second. Is positive. Okay, all right. And then when it goes up, all of a sudden something happens to it. It fails. Let's say we say this is position A, and then at position B, what happened is that is mentioned here that the engine fails. So it speeds up at 75, but all of a sudden it fails. So what happens when it fails? It will turn back down and fall to the ground, right? Okay, all right. Now, the question is determine the maximum height SB reached by the rocket and its speed just before it hits the ground. So what it wants you to find is S here. What is the S at B? And it also asks you to find the speed just before it hits the ground. Let's say C, right just before it hits the ground, the S will be 0, but what will be the speed? V. Okay. Now, what do you think the speed will be when the rocket reaches maximum height? Let's say this is the rocket and the rocket travels up and then at 40 meters the speed is 75 meter per second, and of course all of a sudden before it drops down, what do you think the height will be at the top? Sorry, what do you think the maximum velocity be at the highest? Let's say we throw a ball, when it reach at the maximum highest, what will be the velocity at the top? What do you think it will be?
Lower.
Anyone? Berapa? How much?
0.
0. Yes, it will be 0. When something that is flying and then it reaches maximum at the top, the velocity at the top at the maximum will be 0. Okay, that's correct. Okay, how about the velocity when it reach point C? What do you think it will be? Will it be 0 or will it have a value? Because it says the speed just before, it says here the speed just before it hits the ground. Okay, just before it hits the ground, there will be a velocity. But once it's merged into the ground, then there will be no velocity. So when the question says just before it hits the ground, there is a velocity. And when a question asks what is the maximum velocity at the maximum height, it will be 0. Okay, now, so from here, it also said mentioned that while in motion, the rocket is subjected to a constant downward acceleration of 9.81 meter per second squared due to gravity. Neglect the effect of air resistance. So what is the acceleration here? So the acceleration is, since it's downward, you must include negative 9.81 meters per second squared. Okay, now, so here we have all the values, the variables. Now we need to decide which equation we want to use to solve this problem. Who can give me an idea? Do you want, now, first of all, can you tell me which method you want to use for this question? Basic kinematic equation or constant acceleration formula?
Constant,
Why? Why?
because constant downward acceleration.
Yes, that is correct. So now, which formula do you want to use? Based on the variables that you have, which formula is most suitable to use? First, second, or third?
First.
First, okay. Are you sure? Okay, let's try since you say first. Okay, now for the first question, they ask you to find the maximum height. If you use the first equation, there is no maximum height. Do you understand? There's only final velocity, initial velocity, acceleration, and time. What we want to find is S. So you can't be using the first equation. Do you understand? Don't guess. You need to alert dengan variables that you have. The first equation does not have position. So you cannot use this. Okay? Right. Now, can anyone suggest another formula besides the first? Second or third?
Third.
Yes, that is correct. We use the third equation. Based on the variables given, the third equation is most suitable. So first thing you need to do, you need to write the third equation down. V squared equals to V naught squared plus 2AC in bracket S minus S naught. Okay, now, when you see this equation, you have two different positions. As I mentioned, this is the final velocity. and this is the initial velocity, and this is the final position, and this is the initial position. But in here, you have three different positions, A, B, C. So for you to decide, you need to decide which position you want to choose. A and B, A and C, or B and C. Ah. So from here, the position that you need to choose, of course, will be B. And the variables that we have that is complete is A. So our final will be VB, and our initial will be VA. Okay, that's how you decide. And our S will be SB, and our initial will be SA. Okay, because it relates with two equations. So VB will be what? 0. VA will be 75. Acceleration will be negative 9.81. And SB will be 40 minus 0. So what will, sorry. Wrong. Our SB is actually the unknown that we want to find, and our SA is actually 40. So from here, what is our SB value? Can you please calculate for me?
Madam, kalau yang constant acceleration tu memang kena ada negatif
Untuk apa? Untuk acceleration.
Yang constant acceleration.
Negatif kat mana?
Tak, yang kan dia bagi 9.81. Lepas tu kita assume dia negatif sebab dia jatuh
Yes, because downward. Right now, if you notice if downward acceleration, memang we have to put a negative sign value. That is correct. Yes. You know why? Because it gives a negative, is the opposite sense of the velocity. Have a look at your velocity at point A. Your velocity at point A is going up, right? And we assume going up is positive. So anything that is going down will be negative. Okay? So automatically our acceleration will be going down. We have to put the negative sign. Okay? All right, so what is the answer for SB?
43.8.
43.
Sorry, saya tak tekan tu baca kuasa. Sorry wait. Doktor salah.
Yes. Tolong tekan betul-betul. Can you please type in the correct value? What is the value for SB?
$326.7
What is the unit?
meter.
Yes, that is correct. Okay, so that is the answer. So now you can calculate the speed just before it hits the ground. Can you please do that also? So for the speed just before it hits the ground, which formula you want to choose? Right now you need to find the speed just before it hits the ground. Based on the variables is given, I need you to find that. Okay, you know what? I will give you the answer and I will want you to try to find it yourself. Okay, so VC is actually the velocity just before it hits the ground. The answer is 80.1 meters per second. And because the rocket is going down, so we assume it's going down. So since it's going down, we can add a negative sign to the velocity. Okay, so I need you to try to get that answer. But just to let you know, uh, you can analyze because you already have a complete answer for A and B. You can analyze the question for the velocity for with point A and C or point B and C. You can choose either 2 points. For example, let's say you're going to use the same formula. V squared equals to V naught plus 2AC S minus S naught. You can analyze it with VC VB squared plus 2AC and then SC minus SB, or you can analyze it with VC with VA. In the end, what you get is the same answer. Okay, okay, you will get the same answer. But choosing the 2 points, you can get the same answer. You can either analyze it with point C and B, or you can analyze it with point C and A. All right. So, in the end of the day, for today's class, what we have learned is we have learned how to use the basic kinematic equation, and we also learned how to use the constant acceleration formula. Okay, so you need to do this by yourself, the last question, and try to get the answer. So I hope you got the answer. Did you get the answer? 80.1
Yes.
meter per second? Yes. Okay, it's good. So I think that's the end of the class today. Have any questions?
Doktor, this formula kalau dekat final dia bagi ke macam mana?
Final exam dia bagi, tapi test dia tak bagi. But this formula, you're going to use it many times. It will be so many times until you dah memorize it. But again, I've told you, you don't need to memorize. You can always derive it from the basic to get it. But then again, in the final, formula diberi, but still student get wrong answer. Oh, no, still the students still copy the wrong typo, things happen. Please don't do that. Okay, during the test we will not give that formula, you need to memorize it. So if you don't memorize that formula during the test, you're in big trouble. But that formula is very easy and straightforward. When you do many times, you will almost remember it already. Okay, we're going to use this formula many times throughout the whole chapters, the whole topic. Okay, any questions before I stop the class? No? Okay, so thank you for today's class. All right, I'm still thinking about the others that did not arrive to this class. Okay, thank you.
Thank you,
And
Doctor. Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you.
Thank you, Doktor.